Hi, everyone. So the next topic is machine learning for COVID detection. The COVID disease has infected hundreds of millions of people and caused 4 million deaths globally. The disease has raised serious concerns among governments across the globe, and identifying and isolating people infected with COVID helps containing the spread. Pratik will talk about the use of machine learning for COVID detection and share the case studies. So, welcome, Pratik.
Thanks,
Floor
Philip.
is yours. Thank you.
Sure. Should I share my screen? Yeah. Yes. Thanks a lot, Philip, for the great introduction. To introduce myself again, I'm Pratik. Pratik Katte, based out of Bangalore. Currently working as a research engineer in Niramai Health Analytics, again a company, healthcare company in Bangalore, India. So today I'll be talking about the Niramai fever test, the product that we developed last year during the pandemic in order to help communities and governments and institutions over here to stop the spread of the deadly COVID-19 virus. So we used machine learning for COVID-19 detection and developed a product which we deployed at scale and all over across India. So and then again I'll be talking about the brief different products that we have in Niramai, and apart from the Niramai fever test that we have developed during the last year as well as our main product. So yeah, talking about Niramai, it's a healthcare based company which is established in 2016, based out of Bangalore, and it's dedicated towards working on developing products that helps in diagnosing diseases like breast cancer, Xray, lung diseases as well, diagnosing these diseases at a very early stage using artificial intelligence as well as any modality that we use. So Niramai means non-invasive risk assessment with machine intelligence. In Sanskrit, it also means being free from illness. So many of the products that we've deployed, worked two of the products we developed last year during the pandemic and helped to uh, solve the spread of stop the spread of the COVID-19 diseases. And then we have developed another products like Xray and thermalytics for breast cancer diagnosis. So to talk about Niramai fever test, Niramai fever test is a contactless COVID fever screening services. So as we know, during the COVID-19 last year as well, the main symptoms of COVID were fever detection, high temperature, fever, and shortness of breath. So uh, many of these institutes and governments and everyone were sorry for that. So many of the institutions had many social norms as well as screening services that deployed. So what we came up with is a Niramai fever test where we deploy at institutions levels in railway stations, airports, and corporate tech parks, where people can come in, walk, and enter the campus passively, and the COVID screening would be done automatically without any human intervention or manual interface by the different person, while we maintain and make sure that the COVID norms are being uh, uh, actioned. So uh, there are two types of contact fever test products. One is multi-person and a single person. Multi-person, multiple people in one time can go into the campus without any human intervention or restriction. Passively, they can walk through, and our service can be the fever can be checked. And the single person, the person has to stand in front of the camera and wait for 2 seconds to get the screening. So what we did is the main primary feature of the Niramai fever test product is automated fever detection, where the person coming into the campus can be screened, the face can be detected, and the temperature can be measured, and it would be shown on the screen. And if the person has a temperature higher than the set threshold, for example 35.5, then the alarm would be raised and the security guard and everyone can uh, take the required protocols that are followed, whatever that set in the campuses. So this looks like a very straightforward problem statement of phase detection and calculating the measure temperature, but uh, and as it phase detection is a very diverse and well researched problem statement, as now when we have developed and come so forward in the artificial intelligence space, But in the thermal space, phase detection was a very huge problem because of the varying temperature range and the varying phase information. And the many of the research that has been done on phase detection is uh, on the RGB based images and not on thermal images. So to deploy thermal based phase detection models, there were less open source models and lack of data that were there for train the phase detection models. And the model that we needed was very high inference rate, as well as we wanted to deploy at scale on different locations on low edge computing devices. The model should be able to work on real time devices. So we also, as we are working with the fever, so any external object shouldn't come into the region of interest. That's why we need good accuracy and confidence on uh, detecting multiple faces in thermal image. And also there were many people with the COVID uh, norms. People were mandatory to ask to wear masks, so face detection with people wearing masks was difficult, as plus on top of that on the thermal images. So lack of thermal image dataset was the problem. So another, from the lack of thermal dataset, one of the problems, another problem that we had was thermal image uh, deploying these solutions in the outdoor environments where there are many disturbance at the background and varying temperature with due to the sunlight and different hot objects at the back. Deploying thermal such solution of COVID screening in outdoor environments like railway station and open spaces was very difficult. As you can see in the image, one the if there's a hot environment at the back, so the India is a very hot has a very hot environment. So if you see the person standing in the frame is the details of the images are very feeble, and the region of interest is not that much great. So developing and training the neural network model also is very challenging. So thermal image the deployment phase detection model deployment at an outdoor environment was also one of the challenges. So to solve these two of the challenges of lack of data to train the new neural network model, as well as of less details of the region of interest in the hotter objects in the outdoor environment of thermal imaging, we used with an approach of two steps. One is obviously the data pre-processing step, which will help us to solve the second major challenge was of deploying an outdoor environment, and the second is solving the lack of thermal image dataset using the and train it using neural network model for accurate and high inference deep learning network, and then inferencing with the data pre-processing, and then eventually capturing the maximum temperature of the person from the region of interest. So to solve the data pre-processing step, we used a very simple normalization process, but here's some with a little bit of tweak. So pre-normalized image, we get a perfect curated from the image. We get a three temperature data, but what we do it with that is we do a normalization with the range of 20 degrees Celsius to 45 degrees Celsius. So minimum range below 20 degrees Celsius, we try to push it to the 20 degrees Celsius, and above whatever temperature we get above 45 degrees Celsius, we bring it to 45 and scale it into the range of 0 to 255. Because of this small process of min-max normalization, we can get as you can see in the post-normalized image, where you can see the face of the person is coming in the foreground, and the hotter objects are being lowered, have settled down. So regardless of the outdoor environment or hotter objects at the back or anything, the 22 degree 45 degrees of min max normalization would help in bringing the foreground in the further and expanding the details of the feature, which would help in developing the uh, train phase detection neural network model. So again, after solving the second major hurdle of deploy thermal imaging on outdoor environment, we can train it with the data set what we have collected and pre-processing it, and then training it on mobile net v2 model, which is and getting an output of the deep bounding box of 4 coordinates. So mobile net v2 we use because of its low computing, its advantage of high inference rate on low computing devices compared to other, and again, compared to others, it has a high accuracy on image data set that is published on paper. So it was a very logical thing to use mobile net v2 directly to deploy and to train the images on uh, uh, to train the thermal images that we collected for face detection task. And plus it has a add-on advantage of for getting good accuracies on small region of interest as well. So small faces like at the back, which are like 10 to 12 feet away, also can be used, can be easily detected and accurately detected, get detect with mobile network 2 compared to other neural network models out there that are open sourced. So after the phase detection model, we need to have a temperature measurement where we use inference the data phase detection model on thermal image stream to continuously detect the phase region and extract the ROI expression for and then remove the mask region. So we have a classifier to remove the mask to detect the mask region, the lower mask region, using an algorithm, template matching algorithm, and remove the mask region and then calculate the maximum temperature from it. So another very bigger hurdle was that of the mask. So many of the temperatures that were coming which are higher, so was of the mask as well. And so what we used to do is use a template matching very basic algorithm to remove the mask and take the upper half of the face detection model to capture the highest temperature pixel from the region of interest. So yeah. So now, to after solving the two bigger hurdles of deploying and training a neural network model on accurate and good confidence face detection task, and second is to making it work for outdoor environments as well, which was very much needed. The task comes on deploy enabling the product, enabling the algorithms to deploy at scale on different low edge computing as well as on different devices. So the framework we used for doing this was Open Neural Network Exchange, which is invented by Microsoft. So this framework of ONX basically enables standardization of neural network model format. So regardless of the model that you use to regardless of the framework that you use, like TensorFlow or PyTorch or any of the framework, to train and develop and train the neural network model face detection task, you can deploy it on any of this interference like Android or Ubuntu or Windows platform using this or next framework. So it is in C sharp as well as C++. We have used and deployed on microprocessors as well on small devices, which can be tangled on in robots as well. So it enables interoperability across frameworks and helps in streamlining the process from research to production, and enables you to enable deployment at scale on different devices and platforms. So yeah, again, now after deploying at on different devices and different things, so as from first wave, yeah, last year to the second wave, there was a lot of analysis, calculated thinking and analysis of like, should we unlock the certain places in the city and certain places in the community as well, buildings, campuses. So many of the building admins and heads whoever in charge, who were like wanted to analyze and keep a close look at the varying in the temperature and how many people are getting screened with fever and who are getting elevated temperature, and like what are the protocol that we should follow and what should be done next. So we came up with another statistic, AI machine learning based statistics of machine learning based analysis of providing the statistics of how many people are entering the campus for multiple person, and then calculating the temperature and providing the analysis with how many people are getting elevated temperature and what should be the next protocol. And we'll show the history as well and give the variation of the temperature of the population, which would give them and help them analyze and take the next calculated decision of unlocking or closing uh, the building. So here's a small video of the deployment that we have done in one of the corporate tech parks. You can see the person walking into the campus, while one with the mask and one without the mask, and with following the COVID norms. And you can see the faces are detected with temperature screened on top, um, passively walking onto the campus. This is the system that we have developed and which is deployed across within India. So social impact, talking about social impact, now as we have started working on this Niramai flow test on the due to the pandemic and the need for spread of the disease in the community, and help the government institutions and everyone to take protocols, follow the protocols and everything. So Niramai fever test is deployed across 6 major metropolitan cities across in India, and it has been deployed at more than 1,000 to 1,500 locations across the cities, and deployed at railway stations, tech parks, and hospitals and airports as well, in metros and all, and has been screened more than 2 lakh people a month, and it's been so helped a lot in combating this deadly virus. So to give the gist of the locations and deployment in the product of this Niramai fever test and how we have deployed it. So this is the one of the deployment we have done in a tech park, where we have deployed, and the people entering into the campus with mask can be screened in the security guard setting, then can be check the temperature values, and if there is a high temperature detected, the system would raise an alarm to the security guard. So similarly, we were deployed in banks, and then in public and government offices as well, in office of public commissioners, and at start for them to test as of frontline workers, and we have deployed in hospitals as well, and we tested with many of the clinical trials in the hospitals with doctors as well. Yeah. The solution was a very part of the very inclusive part of the many of the state governments, the Telangana government, and the many governments in India. And it was at start. It was also used as a part of screening solutions at many community centers. So before RT-PCR was a very the kits were very few in at start, and the manufacturing was not much at the start. So RT-PCR were few, and were needed to be used very places with high spread. So this Niramai fever test was also used as a initial test for checking if the person is with fever, and to and oxygen level, to check if the RT-PCR should be checked or no. So yeah, so this was one of the camps that we have done last year during May. Apart from Niramai fever test, we have another solution which we started working on last year itself, was Xray. It's an AI-driven X-ray analysis for COVID intervention on WhatsApp service itself. So in India, WhatsApp is used heavily among everyone, and almost everyone uses WhatsApp through that for daily usage. So what we came up with is so in the second wave of COVID-19, RT-PCR was very less reliable, and many of the doctors were taking the second call by doing an X-ray analysis, and as the burden was also a lot in the for getting the results out in the RT-PCR lab. So doctors, and then for X-ray analysis we need radiologists, which also were overburdened and are mostly in the urban area, metropolitan cities. So with the help of WhatsApp, what we did is to ask the doctors to upload their X-ray analysis image on the WhatsApp, and our X-ray service would give a report of if the person has COVID-19 or not, with 14 lung diseases in merely 2 to 3 minutes to the doctors. So this service was very helpful in rural areas where the radiologists are not accessible, as well as in tier cities where there are not much radiologists there. So early intervention also helped in reducing the burden on the healthcare system, and also managing it properly and giving the oxygen to the people who are needed. So it was the integration into the people's hand or doctor's hand was very simple because of the usage of high WhatsApp usage in India. So this was one of, and we have, like, in merely 1 or 2 months, we like scanned and analyzed, gave out reports of like more than 2 lakhs of X-ray reports to the doctors. This is a collaboration between Indian Institute of Science, one of the premier research institutes in India, and Niramai as well. It's a collaboration between Art Park, ISC, and Niramai. So yeah, it was one of the very helpful services that doctors have appreciated in recent times. So yeah, and again, after talking about the products that we have developed from the last year during the pandemic, which is the product of pandemics, Our contribution to saving lives and diagnosing diseases has been the motive of the Niramai, and the main reason that Niramai establishes and the main product of Niramai is thermalytics and artificial intelligence-based breast cancer diagnosing solutions. This is a solution that helps in and tries to diagnose breast cancer at a very early stage, even before a lump can be felt by the person itself on the breast. So it's more accurate than self breast examination or any physical examination. It's no touch, non-invasive, and not painful compared to other modalities to diagnose breast cancer, which are painful a bit, and as well there's some touch and uh, some non-comfortability. So this solution, thermalytics, provides no touch, non-invasive, privacy aware, and not painful as well, and can be used by anyone, women above 18 years of age and above everyone, can be even used by below 40 years of age as well. Which and While it is there are no harmful radiations that we use to for diagnosing. So it can be regularly, continuously screened after 3 to 6 months, regardless of any limit, compared to other modalities where there's a limit of how many use, because it might give a harmful result at the end, long-term effects. Apart from being highly accurate and non-invasive, not painful as well, and not at all harmful, which can be used continuously, it's portable, light, and small screen device which can be deployed in rural areas, and it is affordable. With the help of artificial intelligence and thermal data, temperature analysis, we are able to use this thermalytic solution, which is CE mark approved and is been deployed at all over India, in the country as well as in the Europes. So yeah, thanks a lot for being patient and attending to the conference. I would love to take up the questions if there are any.
Thank you for the great presentation and talk. Let's see if we have any questions. None so far.
Great.
Let's give it like 30 seconds.
Yeah, sure.
No questions. Thank you very much for
Great.
the
Great,
great
Philip. Thank you.
presentation. If anyone has any question, I guess it's reasonable. They can reach out to you.
Yes, sure. Yeah, they can
Yeah.
reach out to me.
Okay.
Thanks a
Okay,
lot.
thank you. Yeah, and we'll continue in a few minutes.